Gopal Abhindra from the City University of New York. I have the pleasure of introducing Professor Nilay Ganguly. He doesn't need the introduction, but I will do that anyway. Professor Nilay is a professor of computer science and engineering at the IIT Kharagpur, and he has been in the organizing chair of COMSNET's in 2015, I think. 15, and he's one of the well-known researchers. So I had the pleasure of introducing his talk his project is about post-disaster situation analysis and resource management using very tolerant peer-to-peer wireless networks. Professor Nilay. It's a 30-minute.
So I will try to stick to time.
25 minutes and 5 minutes.
So actually we have a presentation, we have a demo, and the demo is downstairs. So Shuja is here. So we try to have a, Shuja told he is doing something high-tech so that you can see it here and also see it there. Something is arranging. But otherwise we may have to go downstairs. So anyway, by this time, I guess except Shayan, everybody has. No, I think Professor Jain also is coming for the first time. Yeah. So this is this project consists of 6 people, 6 institutes: IIT Kharagpur, IIM Kolkata, NIT Durgapur, Kalyani Government Engineering College, IEST, Shibpur, which was B College Shibpur before the starting of the project, and Heritage Institute of Technology. So these are 6 people. And yeah, so some of the pictures, Professor Shadul Das and Professor Kumar Ghosh and Shubir Vishwas was helping us in the project. So this is the central goal. In one shot, this is the goal of the project: building a low-cost, fast deployable solution for post-disaster scenarios by using authentic situation information and several disaster management services. So I think there are 3-4 keywords: low-cost, fast deployable, authentic information, disaster management services. So this is, if I think carefully, these are the key things, and that these 3 keywords actually matches into 3 layers of the project. One is fast deployable low-cost networks, and you have various sorts of, we have developed various sorts of services for that, how to have fast deployable low-cost network, and we will give a presentation on this. Are we giving it downstairs, or we have to do it here? You can view it here. Oh, so there will be a live demo here. Otherwise, people can also go downstairs. And then from this networks, there are snapshots which are coming out from the network, snapshots which are coming out, and which are integrated, and situational awareness is developed through these snapshots. And there are various sorts of work which have been developed in this project, like localization, route discovery, crowdsourced media, Twitter interaction, and then various sorts of summarization. I will, so in the interest of time, I will just highlight 1 or 2 of these topics. And then we have the disaster management services, which will show a package which we have developed. So let me come into the fast deployable low-cost network idea. So in this fast deployable low-cost network, our idea was to build up a multi-tier hybrid ad hoc architecture for post-disaster management. So it's a multi-tier hybrid architecture. So if you look into there was this long-range Wi-Fi networks or Wi-Fi communication, long-range Wi-Fi communication. Then there are some data mules, and there are some static data centers from which this data mules collect data and bring it to this Wi-Fi center, and this Wi-Fi centers then transmit from one center to another center, and accordingly this data is taken out to the control tower. So if this is the basic architecture, if we keep this basic architecture into consideration, just have it in our mind, then there are various things which have to be done. One is we have to have a Wi-Fi tower. Which we put up. Okay. Then we have to have a information kiosk. So things are dropped here, which are taken by the Wi-Fi there. So we have to have a Dropbox sort of thing, which we bring. Then data mules can be in various forms, but one form which we have explored in this project is UAV. We have run UAV. I think many of you have seen us running UAV. This time we are not showing UAV running, but I think many of the times in the during our project presentation we are running UAV. And then there are smartphones which have the primary data from which things are coming. So these are the components, and we also have developed components where we are having actually divide this Dropbox to Dropbox and Dropbox to Dropbox communication. So this is in general. I am just trying to give a.
So how much time does it take to deploy this nest?
Yeah. So that's I will come to that. So anyway, since you have asked, I will tell that what we understood from the project proposal to implementation, that this is not a good implementation. So this building up this tower is not fast deployment. So we did this, and it has to be, see, you have to actually put it with some plasters, and we put it up on a roof and it fell. And luckily that nobody died, but the entire thing fell in one storm. Okay.
How high is
How high was it?
That was
Yeah,
it's a tower. 20 feet.
20 feet.
Yeah, 20 feet long. But regarding the problems, it already went down and the amount of time and cost was huge. So we have already started exploring alternate communication methods.
So what is the, if it's 20 feet, I mean, I think the expert is.
Yeah.
So we had put it in a roof of a private engineering college in Durgapur, and the entire thing fell down. So we were lucky that nothing happened here. I think it was not installed properly. So this is the hardware part. Then you need a software architecture actually to implement this. So software architecture, if we build up a protocol stack that way. In our way, we define a protocol stack. Like we have, first we need a P2P connectivity. So we need a P2P connection stack. Then once this connection is developed, then you need the P2P file sync. So developing the file sync, and then once this file syncing is done, then the post-disaster management services has to be built upon this. And one of the important post-disaster management services is building up the map. So because one thing we understood after talking with many people, that in disaster, one of the most important problem is information. That people are not sure what is the information or how much relief is needed. So always there will be undersupply or oversupply. More supply in certain places, less supply in other places. So all these sorts of things are important. So information is very important in understanding what really is needed, because ultimately there will be, when disaster is there is panic, and with the age of fake news, there will be all sorts of fake news going. So authentic information is not there. that is what we can, as scientists, make that small contribution. Okay. So these are, so then one of the important things there is developing a map of the disaster prone regions. Okay. So these are the, and then above that we have end user interfaces and various services like Twitter services, etc., those sort of services. So this is how we conceived our program, and then we built, I am not going into this, but we have our protocols for each layer. So we have this VPN Connect, which does the connection, which builds upon TCP protocol, but it has its own layer. Then we have the DTN sync, which is a P2P sync protocol, syncing files, and above that, and then for the PDM part, we have this crisis mapping. So crisis mapping, we did it in two ways. One is the online mode. Online mode means whatever data we are getting, we are taking it to the cloud and trying to build up the crisis map. That is one thing which we did. And another is the offline mode. Offline mode where data is, I will come to this offline mode, where data is collected from various peer devices and accordingly activated. Okay. So I will come to the individual part, but then after building this entire package, our so I am doing only the presentation, so the entire work is done by many of them. Out of these 4 people are very important. So there was a huge lot of field testing done. So field testing, first field testing we did, we took Durgapur as a base, and there was no disaster as such, but we did a field testing on Durgapur NIT and around NIT, and because there is this college is how far? 6 kilometers. This college is 6 kilometers, and this is NIT and this is this college, and this is NIT and this is this BC Roy Engineering College, 6 kilometers, and we built up a test bed around there. And some of the key observations were that like deployment of long-range Wi-Fi is difficult. I have already discussed this, and then again this is what we see, that observed data often gets some system specification, which is pretty obvious. So, but somehow those has to sink in our mind also. Those has to sink in our mind as a practitioner, that how much this observed data and things are deviating, and accordingly we have revision in simulations. The second demo is on Sandesh Khali. Sandesh Khali is a place. You know what does Sandesh means? Sandesh means message. So, but Sandesh also means some other thing.
What is Khali?
Yeah, Khali is its only message. Khali is
Khali is message.
Yeah. So Sandesh Khali is a place where there is river. And this place, so as I think Animesh was pointing out, that we have been continuously in touch with the government agencies, and they are doing various mock drills, and we have gone and participated in all these mock drills and tried to talk with people, understand, etc. So yeah, you see, yeah, okay. So I'm just telling you, Sandesh Khali is one which is affected by flood. The disaster specification is flood. There is a river, and around that river that we have done. And so one thing about flood, so since flood is what is a take home? There are many take homes, but I will just, so one thing it is understood that flood is some disaster which is cyclic. So one important thing which we understood, that beyond post-disaster, pre-disaster evacuation, etc. are also very important, and can our post-disaster mechanism can be extended to pre-disaster. And here one important thing that I think Professor Ahuja knows, and we had discussed all this thing, because we are putting this mesh around villages and trying to collect data from these stations. So ground area deployment of mesh box systems. It's not that when you are having disaster, you go and, so again culturally that is also not very good, because you go and put mesh, nobody knows how to use that mesh. So it's both pre-disaster evacuation this will help, and post-disaster the mesh will help. The second part which we did is called a Ambi. Okay, so it's a place where which is also it's done by flood-based disaster, but cyclone is another important thing which happens. So cyclone is another important thing which happens. So this is a cyclone-based disaster which is more important. So and the things which we learned is design and incorporation of intelligent information aggregation summarizing. The cyclone happens in a larger space, so information aggregation and summarization policies are very important. And so can we, when we are trying to build up this network, can we have this information and sensitization? The fourth which we did is in a more industrial area, more it's not a natural disaster as such, but in the ASP DSP in Durgapur, the steel plant, where there is fire service and fire-based evacuation, so fire-based disasters, and there also we took these things and asked them that whether they can actually use this for fire-based disasters. So this is very important. What they are telling is response. So here there is, see, disaster you have rescue and there is relief. So in fire-based disaster, rescue is very important. So then when we have to build up our devices, we have to remember that our device has to work in such a way so that it can hasten rescue, which is itself very fast. So that is the point which we took up. But the good thing is in this fire type of condition and in natural type of condition, in fire type of condition it may happen in a urban setting, but internet may not be a problem. So in most of the tasks where we thought that internet may be a problem, but in fire type of situation, internet may not be a problem. So this is overall we learned, and then I am coming to individual. So one thing which we understood in all these cases, so for this and for this, that we have to build up the crisis map actually offline. Crisis map online will not be possible because two things are there. One is the weather may be very heavy, which actually creates problem with GIS, with GPS, which creates problems with GPS. This is number one. And number two is there is outage, electric outage in large areas. So if you do any sort of algorithm, ultimately your power will go down and then everything is gone. So yeah. No, all the devices which we have taken, we may have taken some devices, there are some battery, so there is no, there are already some powers already present in some form of battery. Or there may be power in some places where you can go and take some power, charge it and come back. But the general thing is means you have to be sensitive with power. So this is the basic point which we take that.
In terms of power consumption?
Yeah, in terms of power consumption, all the algorithms which you have to develop. So that has to be.
Besides those main boxes, we call it XOB. These boxes are already.
Those boxes, we call it XOB. These boxes, they have already the battery powers and they can serve up to 48 hours without any external electricity. We have already tested that. Yeah. No, see, I am talking about the individual boxes that we are going to deploy in the.
The mesh box, so one of the central things is that mesh box, so that he is telling will run for 48 hours. If we have good algorithms around.
Depends how much data you are transmitting.
Yeah, how much data?
If you are transmitting media, etc., it will start.
Yeah. Yeah, but maybe.
Go over to details. These are the costs.
Yeah.
I don't know where disaster will strike. Right?
Yeah.
Given that fact, what is that town or village or city from which I develop the maps?
Now, so this is, no, I am redrawing the map after disaster as well.
After disaster.
Yeah. So this is a map.
This is done offline after disaster.
After disaster. So the idea is that there is a map, but after disaster has struck, so maybe this picture would look good. That, see, in the, so you have transportation in post-disaster relief work face several issues, like there is broken road, landslides creating blockage, difficulty in using. So these sort of things happen. And one interesting thing, so which even without disaster today I went into a road which was a even knowing Kolkata so much, went into a road which was a dead end. Because I was trying to enter the bypass through some road which was going. So one issues which happened is, this is what we understood from discussion, that rerouting eats a lot of time. Because people go there, then sees that nothing is, you cannot go there, then you come back and reroute. So there are some things which we have just collected, that in this Mirik earthquake, it took 3-4 hours. So those 3-4 hours are the golden hours, and those are problematic. So even if one person knows, can it be transmitted? See, please don't go there. In the worst case, that please don't go through that road, go through other roads. So that route discovery part is a very important thing. So it's a route discovery, and route discovery leads to map generation. So the idea is, the basic idea is, we try to build landmark database. We try to build landmark database using the inertial sensors which are there in our smartphone, and which we are transmitting. And with this landmark database, we try to create the map. I'm not going into the details. So there we have two systems in place. One is Urbanite, which creates the landmarks database, and second is the CrowdMap. From this landmark database, it creates back through crowdsourcing it creates like the map. So this is the map generation which happens just after disaster. So I think in the interest of time I will just go. The second thing is about this UAV. This is again from our experience that we have first. Actually, I think we begin to run UAV even before when UAV became popular. I think in the first session also we began to run UAV. We made our own UAV and ran it. But slowly what we understood that UAV running and seeing is very good, but really using it. Oh, okay. Oh, just 5 minutes.
Yeah, 3-4 minutes.
Okay. So anyway, running in the UAV is fine, but really using it in proper shape is important, is difficult, because what we found that beyond the wind speed it doesn't work. Okay, beyond the wind, which is not even mentioned anywhere, that beyond the wind speed it will not work. It doesn't work under certain, if the air becomes heavy, it doesn't work. So all these sorts of things we begin to realize. Then we try to build up a flight simulator sort of model, that if these are the factors which are there, then and it may promise. There's another things which happen, that which our UAV also broke down, that it may promise that it will typically this Sundarban area there are islands, so you want to move from islands to island. So it may promise that it will go to 10 islands, but ultimately after 5 islands it goes down. So we need a good simulator to understand that what is the promised thing and what we exactly. And so we did a lot of simulation, and it's not only simulation, but we then again ran the UAV with this thing, and we found stable. So let me just gloss over because in the interest of time. So just this is for advertisement or I guess there was a lot of interest in the local newspapers. There was a lot of interest in local newspapers. There are startups, there are achievements, there are publications. On the whole, as a PI, I think I am pretty happy with this development. That it has gone through all directions. People have taken, left their livelihood, left their job, and trying to do this thing. So people have got excited, and then also academic pursuit has not stopped. It's not that people have just gone for industry, academic pursuit. So going to the next layer, about the situational analysis and snapshot integration. I am just talking about Twitter, that OSN, how to integrate OSN or how to integrate Twitter's information and retrieve something useful. So, just to give you a feel that when you see Twitter feeds coming after a disaster, you will see, oh my God, my life is in danger. Okay. So what do you do with this? So there are a lot of information and most are junk information. So it is very important for the person to write that tweet, I understand, but for me it may not be very important. So for me it may not be very important. So then one important thing is that there is a deluge of information, but one has to bring out situational awareness information, the information which actually produces situational awareness. So that was one thing which we did. We took situational, non-situational and divided it and then did some summarization, good summarization of situational tweets and presented it to the practitioners. So presented it to the practitioners to see that how this good summarizations are going. So one important thing I will tell you here that we presented to practitioners like UN OCHA. So United, what is the full form of UN OCHA? So anyway, the disaster relief organization. So most of the time, many of the time they were telling that you are doing good things, but most of the information we know. But the summarization was by per se good, but most of the information we know. So there are so which is good for a publication, but ultimately a disaster relief organization may not find it very useful. So this was our first realization after we did this work. Then what we understood is that it's not only summarization which is important, but sub-effect categorization is important. There are various sub-effects, and sub-effect may be types of sub-effects like rescue, relief, law and order, and also sub-effect with respect to space, like bridge collapse, that is at one space, roadblock, that is at one space. So what we have to do, if we have to do good summarization, we have to do good summarization based upon not only the type of events which is happening, but also along the space. And this also relates with our offline map. So we have to have the summarization of space and relate with the map, and then people can really use it.
Causality analysis.
Yeah, we do causality analysis. So after this, so it developed in various stages. It's actually 2 PhD work which came on. So one is after this you then do the causality analysis and also map needs with what relief has come. So we also map need with what. So I will just, so this I can talk many hours which you may object, but I will tell you some small anecdotes about this. So again, one sort of work which we had to do in Indian condition is not all tweets are English. So there are English tweets, Hindi tweets, Bengali tweets, all vernacular tweets. So I will just give you one small anecdote. When we take English tweets and take the name identity, okay? Just name, place identity, place names from the English tweets, and we take the Hindi tweets and take the place name from the Hindi tweets. We see there are distinct differences. As soon as you see the Hindi tweets, the place names are more villages. and English tweets, they are more semi-urban places. So this is very interesting, means that we have, so because there was a lot of debate among us that, okay, for academic debate you can do English, Hindi and tell one paper you tell Hindi, I have done one paper you tell English and Hindi I have done together. So those things we are expert at. But the point is, again, the utility came out very interestingly, that we see that all the areas which are little bit at the hinterland, vernacular tweets are very important. So there are, I will just point out this, there are another ominous thing which happens in disaster, which is a lot of communalization happens. Even when it's not with shooting, I'm telling even natural disaster, there are a lot of communalization. I will just mention this because I need it for a next slide. So,
Do you have empirical evidence on that?
Yeah.
You just have your-
no, this is a published
For
paper.
colonization.
Yeah, it's a published paper. Yeah. No, it's a conference. Yeah, it's in a social network, it's considered a software. This is in Sydney next week. So one part is this tweets. The other part is WhatsApp. So WhatsApp is another part which we cannot, which perhaps is more effective in Indian conditions than even tweets. That people are doing a lot of WhatsApp, which we collected WhatsApp data from Doctors for You. So we had Ashok Prokasta and IM teams have a very good connection with Doctors for You, who has also given us a lot of insight throughout the project. So Doctors for You, we collected all tweets, and what we see from this WhatsApp, that from this WhatsApp messages we can actually get various phases and various medical requirements, and accordingly we can plan. So if we can have a good retrieval algorithm through which we will understand various phases of the disaster, like there is the heroic phases where there is the first week after disaster where we see a lot of injuries and trauma. In the second, in the honeymoon phase, next 3 weeks, we see water contamination, pregnant women and children. So these are the people who are getting affected. And then resolution this next 3 weeks, you see that waterborne, insect-borne diseases are coming. So you can understand how things are setting in if you just can track the WhatsApp group, and you can accordingly plan your actions. So as computer scientists, what we can do, we can give information, it is others who can work on this. So there are several publications around. So to conclude, again, I think this is what Animesh has also told, that this is, I just wanted to conclude this with one achievement. It is that Microsoft Research had this artificial social intelligence call, I think from all over India, young people, young researchers, young faculty members, they gave four projects ultimately, and Saptarshi, who is an India, is one of the projects leader, and he has come runners up, and they are funding, they are giving another project to run this. So coming to the third thing, this is a disaster management services, and we have actually built up an entire suite to run the packages. So I have a good video. So if it's so should I show the video? I just.
Engagement. Problem of raw material supply, incorrect or no training facilities, and inadequate counseling services. Very good morning. We are going to present an information system for the next generation collaborative and responsive communities. The basic problems which are faced by the rural communities are lack of disaster resilience, dearth of market linkage,
problem of raw material supply, incorrect or no training facilities, and inadequate counseling services. The first problem, which is the disaster resilience, it requires some emergency management services, and the rest, they require some life and livelihood services. So with these objectives in mind, we introduce an interactive community-driven information system that helps the day-to-day functioning of the self-help groups, who are acting as the micro-communities within a village. So there are two broad functional areas, which is the emergency management services and the life and livelihood services. The basic objectives of our information system is to form a disaster-resilient community for better disaster management, to empower the SHGs to interact and collaborate among themselves and their different rural development authorities to share their problems and search for solutions, and then to enable the involvement of SHGs to participate in local governance, then to support them to access the various skill development training and improve their livelihood, and finally guide them to establish the market linkage to sell their products and get raw materials. So this is our information system, which has got two broad verticals, the life and livelihood vertical and the emergency management vertical. These are the different roles in which a user can use our information system. One is a volunteer, next is the emergency management agency, next is a donor. Then we have the self-help groups, buyer of finished products, seller of raw material, vocational training provider, SHG cluster federation. Then we have got this local administration and the health and hygiene experts. When in the emergency management services, we have got three functional areas: generating alerts, doing this analysis, and then this resource management. In the alert section, the portal provides alerts for emergency situations as well as some important points of contact. In the analysis function, the data collected from the sources like interactive SMS, phone-based app, and online form is processed and the reports are generated. In the resource management function, the site can also serve the purpose of collecting various resources and distributing them on a need basis. In the situational information facility, we can actually have different important situational information. In the emergency notification, we can have different kinds of G-warnings and warnings and all. In the important contact facility, a person can actually look about important contacts in his or her location. In this help me, a person can actually request about some resource or some services after filling up this simple form. In the
So you did indicate that you are assuming that there is a power outage and that you would have battery backpacks to help address that. So how about phone network? Is that also out?
Phone network.
Telephone network, both landline as well as cellular.
So what we are assuming is phone network is, most of these are out. Because,
So phone network is out.
yeah,
And how about access to the internet?
that's out.
So the question that I have is, how do you then finally provide access to the global network?
No, so there, we may have one or two satellite phones through which we use it. Means there are some aggregation point where,
So you are assuming that there will be some satellite phones.
yeah,
The bandwidth for that will be extremely limited.
yeah, that is.
Not kilobits.
So then we have a lot of aggregation, local aggregation algorithms also. We are actually, so that's
of Facebook, computer, and so on and so forth. I guess all of this is being generated from within
yeah,
as well as from without.
from the
Right? So all of that has to go through the satellite network.
So if you ask me to criticize my project a little bit, what is this entire work of Twitter algorithms, how that will be exactly, where the summarization will be done, whether we can have some small sort of summarization at the node itself. So those sort of architecture we have really not done. I take your criticism, I'm telling you.
So basically, the underlying network is an add-on network.
Yeah.
So how much time does it take for you to set up the add-on network?
How much time?
Does it take to set up the add-on network?
So we are assuming this thing will be already there. The
I aren't you assuming that, for instance, there is a disaster, let's say in Pittaurawad?
There's a disaster.
There's a disaster in Pittaurawad in
Yeah.
Uttarakhand, right?
Yeah.
That you would move equipment and people to Pittaurawad
So all
and
this,
set this up within minutes.
so all these are very small devices. We are not giving that big device.
No, but still you had these routers and switches and Wi-Fi.
No, Wi-Fi we are not taking. So that Wi-Fi is out. Otherwise, we have small drop.
Sir, I guess I may interrupt.
Yeah. My concept of a disaster management system is that when you know that a disaster has happened, you fly in or drive in with all the equipment and people, and you set this up
Yeah.
so that once you reach there, within 5 minutes and 30 minutes,
Yeah.
everything is up and running.
Yeah. So that is, see, all our devices, what we are using as device, we are using the Dropbox, the mesh box, and mobile phones, and USB. These are the three things which we are using.
So they need to be installed and they need to be
Yeah.
part of the network.
Yeah, they have to be. Yeah. So see, if you think that the mesh box will be put in places where we can access. See, there are two models. One is because of this pre-disaster, we understood that mesh box. One thing is what we are suggesting that this mesh box should be put in villages for disaster preparedness. Okay. So now let us assume that for disaster preparedness, the place is not disaster prepared. So we have to take the mesh box, install them. Okay. Now where do we install this mesh box? We install this mesh box only at places which is accessible. Okay. Now second thing is where there is inaccessible, already there are mobile phones, and these mobile phones will be taken by the disaster relief people. Okay. They are taking the mobile phones and but they cannot come back immediately, and now what will happen, this UAV will move and take data from this mobile phones and come back to this mesh.
So the UAVs are working as data links.
UAV are already tested.
So if two phones have to talk to each other,
Yeah.
data being operated.
Yeah, data being operated. Because if they are
Wi-Fi towers sitting out there.
so Wi-Fi tower.
Sir, I guess I may step a little bit. The whole architecture is a very modular thing. So without using that box, you can set up the architecture only using the mobile phones we already have. You just, yeah. Yeah, sir, that's the beauty of the application. The application you need to install that we have already developed that can work without any cellular network or without any conventional Wi-Fi network. It can create the ad hoc network automatically based on the DTN technologies. It's a delay tolerant network that it can form via the Wi-Fi adapter you already have. You don't need any central connectivity at all. That's the first step.
So because actually if we don't have the P2P layer, there are several problems. Like if I have this information box, okay, information box, I want 10, 15 people joining in this information box. If we don't have the layer, P2P will not work. TCP, through TCP, so what I am wanting is this information box is there, and I want maybe 50 people putting their data in this information.
So, okay, now that you decided to have a P2P network, now how do you address the authentication problems?
Those problems are there, so I take those things.
You're not going to distribute password.
Yeah, so we are assuming that in this, yeah, that problem is there. I take that. I take that.
Yeah, we are trying to form as much as we can get the crowdsourced data.
So my point was like,
That problem is there.
the ad hoc networks, the fundamental problem that I have always seen is that of authentication. Because there are this different sets of people involved, right, in using the ad hoc network. There are these police people, there are these health workers, there are engineers, and of course, users. So how do you make sure that you can operate
Yeah, the idea is after getting the crowdsourced data from that called the various layers of people from the various such as the rescue workers as well as the affected people or maybe the police or
But how do you authenticate? After getting there are various things, but how do you authenticate? That's sort of, yeah.
The protocols will run nonetheless.
Yeah. So that problem is there.
Are there any questions from the audience?
That issue is there.
Another thing, I guess, that you have questions regarding that Wi-Fi tower. That's maybe problematic to set up. It requires around 24 hours to build up the whole solution to put it up. Yeah, exactly. It's 20. No, that long range tower one that we are talking about.
20 feet is not hard to put up there. 20 feet hours.
Sir,
Yes,
no, it's not. Sir, we are using basically here omnidirectional antenna. Antenna angle is 5 degree. So putting 6 kilometer range with two tower in same direction, there is a problem. And we found that this problem. It is not direct, it is omnidirectional, it is directional antenna. Antenna gain is 5 degree and we are putting these two antenna in 6 kilometer range. And
it's not antenna.
So it's not only just the stalling but the calibration.
calibration is required, yes.
Yeah, you have two people and keep rotating. Yeah.
The second is
nothing else only then I'll explain the last thing. How essential is a holy day to carry on these experiments? You know about that? Another question? Let's move on.
Yeah, I have some.
So
I think
So we want to show the demo.
then we can see during lunch. Now, so it's only 17 minutes. You have to catch 5 minutes.
Just one question only. So it is actually heavy system I feel. So you went horizontal manner system. Why can't you divide services vertical manner? What are services? Can you design a simplified system for one service? Why don't you follow that incremental approach? That was the question actually. Is this the way to develop a system? Heavy system you are developing, suddenly something doesn't work. Every system is up. So vertically, can you modularize it? I don't know.
No, it's a valid question, but what I can say is all these layers are not needed in all the programs.
Yes, that's what. So you start with the simple service.
So
and we operationalize this. Add another services so that
That is why what he was trying to say that even a small P2P network, so the flexibility is there. Even without mesh box, it works a small P2P network. And even all the layers are not needed for all the services. So those are not needed as
the question becomes easy. And you get more confidence.
There is no service running which does not use
theoretically it can run. So if I am just having a small number of people putting data on the mesh box, then I don't need a P2P network immediately. But it can just work on that. So immediately you instruct
TCP service available without having to go through P2P layer.
Yeah, I'm not sure about that you can answer. Is the TCP, can we bypass the TCP?
Can we carry this discussion?
It's
It's a good talk. And again, there's always a tomorrow in research. It's a future work. And if any problems are already done, and then I'm sure the group will take his comments.
We have already deployed a test box and the mobile device.
Some of the comments, Professor,
That comment
they
is also
from
the-
authentication, which is
So the comment he asked that do we have a bypass of P2P? Do we have a bypass of P2P? That is it, because in many cases P2P becomes heavy. Can we use without TCP? That is the
your observation on authentication.
that is an observation of
As long as it's
yeah.
thought about it.
Observation of authentication, we already know that problem is there.
So let's thank Professor Gulati.
Now we'll be starting with the next panel, and that is the last one with us from here. So may I ask the representatives of both teams to come to the front. So a representative from Team Micronet.